All right, lesson number 17 here. We are talking about area of a circle. So yesterday we were circumference, which is the perimeter. Now we're talking about area. Now, area is the number of square units. All right, so how many square units will fill up a circle? This is why when we deal with pi, we're going to have those decimals that we're dealing with it. So first problem is a little bit of a throwback here. They are dealing with circumference. This is a style of problem that we want to make sure that we're comfortable with, and that is realizing that it's not always just about throwing things in and just multiplying away. It's always a great thing to get your formula down and then plug in what you've been given. So they want us to find the radius of the following circle if the circumference is blah, blah, blah. Okay, so formula. I'm going to use pi times diameter, all right, because that's what I always end up using. I don't like to bounce back and forth. We could use 2 pi r, all right, but I'm going to start with this one. So the big thing is they've given me this 37 and 6800ths. That is the circumference. So instead of the letter C, you're going to use 37 and 6800ths. Now, this is pi, and here they're telling me to use the 3.14. Now, when I multiply it by d, all right, then I can end up solving my one-step equation here. So this is why we always just don't want to get into multiplication and guess and check. We can solve our equation, and we can just plug it right in. So if you reach for your calculator and you type that in, 37 and 6800ths divided by the 3.14, oh my, crisp clean 12. But they asked me to find the radius, so take the diameter, chop it in half, and hello, radius. So it is 6 inches there. There's my answer. So like I said, it's good to always get the formula down first and then to plug the information in. What we're going to be looking at here is where does that formula come from for an area of a circle? Not just, well, we always just tell me it, write it down. We actually, we've got a way that it comes about. And here's the main idea. You take your circle and you cut it up into equal pieces. They're talking about 16 pieces. So they've shaded the top half, left the bottom half unshaded. If you actually take the pieces out and then slide them into place here, you're going to make what kind of looks like a parallelogram in a way. All right, you're going to get a little slant that's there. So what they end up doing is they take that end piece and they chop it off. By doing that, then they take and they put it over here, all right, it ends up forming a rectangle, and that's what they've got going on here. So pieces of it there, all right, if we look at it closely, they're looking at one of the pieces, this top part, this up and down, that is the radius from the circle. If we look at this, all these little kind of bendy lines, because again, it's the portion of the circle, this is half of the circumference. And again, it's this particular portion. So to find the area of this shape, all right, we would take the radius, all right, and we would multiply it by half of what the circumference is. So okay, so let's kind of clean this up a little bit. What is half of the circumference? Well, I'm going to use, all right, the 2 pi r formula because I've got a radius that's over here. We like to keep the same letters when possible. So let's look at this. What's half of 2? Well, 1. Yeah. So I've got r times pi times r. Well, when I multiply r times r, I get r squared. So it is pi r squared. There's your formula. Area is pi times the radius squared. Now again, if you're kind of going, Mr. Savage, where did that come from? I don't see that. All right. Don't worry about it. The main thing is that you can use the formula. We just like to give you the behind the scenes a look there. All right, just a little bit. No, there's nothing crazy about that. All right. Oh, let's head on down. Let's head on down there. All right. Kind of a basic, kind of a straightforward problem here. We got a sprinkler. Okay, rotates in a circular pattern, sprays water over a distance of 12 feet. Was the area of the circular region covered by the sprinkler? All right, express your answer to the nearest square foot. Okay, so we've got a sprinkler. If it's, go ahead, do your best sprinkler impersonation, right? Oh, okay, I'm done. All right. Yeah, it goes out 12 feet there. So if it's going to cover all the way around, your circle is going to look something like that. So it's going to cover everything in there. That's why we know we're using area. So that's why we're going to use pi r squared. The radius here is 12. Now, they're not telling me what to use for pi, so I'm going to use 3.14 simply because Well, they want the nearest foot. That means I can use decimals here. So when we plug it on in, 3.14 times, again, reaching for my calculator, 12 squared, we get 452 and 1600ths. Ooh, my, that got a little shaky there. All right. We're talking about area, so it's feet and then square. That's the number of squares that would fit inside there. Again, nearest square foot, so we would have 452 square feet that we're looking at. All right. So again, the formula, all right, plug in what you've been given. And remember, the 12 squared, that's the 144. We multiply it. That's different than this. Again, this is how many squares can fit inside the particular shape. I don't want you to think that's where that information is coming from. All right, example 3. Now, we like this one here, all right, because this one starts to get us to start to analyze. It's more than just simply, well, let's just kind of plug it in and let's see what we get, all right. Let's get a picture down, all right. No, you shouldn't be scared of the pictures, people, all right? That's going to help organize your information. Watch what's going to happen here. Okay, we got Suzanne. No, she's making a circular table out of a square piece of wood. All right, so there's your square piece of wood, all right, and she's going to make a circular table out of it. So she's going to cut a circle out of it there, something along those lines, all right? The radius of the circle that she is cutting is 3 feet. So right there to right there, that is 3 feet. We want to know how much waste will she have for the picture, so for the project. So idea is if she cuts it out, this part's going to be the scrap that's left over. In other words, the waste that we are dealing with. So in order to figure that out, if we find the area of the square and take away the area of the circle, then we're going to be left with what's the waste. In other words, what the scrap is. So let's pull out the information. The square here, if from here to here is 3, well, how far is it from there to there? It's also 3. So how wide is that square? Yeah, it's 6. That's 6 by 6 there. So 6 times 6 is 36, so we're going to have 36 square feet. Now, for the circle, remember we use pi times the radius squared. Well, I'm going to use 3.14. They didn't tell me what to use, so I'm going to use a decimal because we're talking decimals here. I'm not going to leave it in terms of pi, even though it's kind of easier a lot of times. I need a number, all right? I need to know how much is going to be left over, and leave me that subtraction problem is not going to give me the information. The radius here, go back to your picture, it's what? Yeah, it's 3, so it's 3 squared. So if you punch that in your calculator, 3.14 times 3 squared, in other words, 9 there, you're going to get 28 and 2600ths. So let's do a little bit of a subtraction problem there, all right? And ta-da! Now, they did say, oh, look at that, nearest foot. Oh, I'm so glad I read the directions. So it's going to be approximately, it should be a little wavier there. Yeah, did you know that there? Did you know it? Yeah, that's your approximation symbol. So it's about, so it's an equal sign, but it's a wavy one there. It's about 8 feet, 8 square feet of waste. Now again, we say square feet even though it comes second. It's one of those kind of weird things there. You could say 8 feet squared to be fine with it. All right. Yeah, quality problem there. We like that one there. And let's see what's next here. We got a circle. It has a radius of 2. Find the exact area. All right. Well, the formula is pi r squared. The radius is 2. 2 squared is 4. Oh. That's it. That's all we need, 4 pi. Again, because they want the exact area. Remember, we leave it in terms of pi. If the area is 4 pi and they want me to use 3.14, just type that in your calculator. 4 times 3.14. All right. We don't want to use the pi button there because of the rounding that's involved, and that could give us something different. 12 and 5600ths. Units of measurement, centimeters, and then squared. All right. Technically, this should be 4 pi and then centimeters squared as well. We still should have our units of measurement. All right. Let's see what we got here. Exact area, radius of 7. So again, formula is pi times radius squared. Take the radius and square it, you get 49. So it's 49 pi. All right. And then, yep, centimeters squared. That's it. Again, exact area. You should kind of be loving it because it's less work. Here they're telling me to use 22/7 for pi. All right, I got to multiply that times the 49. Oh my goodness. You tell me there's cross division here. It's almost as if that's the reason why they told me to use it. And yes, that is why we use the 22/7 is because, well, we have cross division. All right. A 1, and is that going to be a 7 there? Yeah, it's certainly. I'm sorry, a little too much excitement for cross division. I know. 14 carry the 1, 154. All right, 154, and then we are in centimeters squared. All right. And then the last one here, what's the circumference? Okay, bounce back, formula for circumference. Hello, pi times diameter. All right. So what's the diameter of this circle? Well, if the radius is 7, then the diameter is 14. So I would take 14 pi. All right, they didn't tell me what to use, so I can leave it as 14 pi, or I can use my 3.14. All right, and then if I did that, I'm going to end up with 43 and 9600ths. Maybe I didn't want to use that. Maybe this is a good chance for your fractions. Yes, because it's 14 times 22/7. Oh, cross division. 2 times 22, 44. So again, when we look at all of them here, and this is your centimeter squared, centimeter squared, centimeter squared. All right, all of those would have been quality answers since they did not tell me what to use. And all right, so last one here. Find the area. Oh, another good one here. So this is one where we want you to try it, okay? Because it is a lot like how we started off. Did you see the connection there of how we started and how we're finishing it there? Try it yourself, all right? See what you can come up with here, and then we'll end up talking. So pause the video, in other words. All right, welcome back here. Did you pause it? Okay, I'll trust you. Find the area of a circle that has the circumference of this. So my circumference is pi times diameter. Okay, so I'm going to plug that in, 10.048. Now, for pi, I'm going to use 3.14. The reason why is this isn't a decimal. All right, so we need that. So it's going to stick with decimals. Divide both sides by 3 and 1400ths. Let's see, 10.048 divided by 3.14. Oh, that's not bad. It means a diameter of 3 2/10. But if I want the area is pi times radius squared. So if the diameter is 3 2/10, your radius is, yeah, it's half of it. So it's 1 6/10. So now is where I can leave it in terms of pi, whatever I want. I'm going to use 3.14 here since we were using 3.14 before. All right. Actually, I'm going to put down the exact answer as well. I'm going to do 1 6/10. All right. So if I end up squaring that, you do get 2 5600ths. So it's 2 5600ths pi. All right. I would take that. You could also then do your multiplication. So 1 6/10 squared times your 3.14. And again, you can punch it all in your calculator at once. 8.0384 feet squared. Don't do any rounding. They didn't tell you to round it all, so don't take it upon yourself to do rounding. That's why we're leaving the exact amount that we've got there. Sometimes the circumference is going to be larger than what the area is. That's just, it depends on the shape that we are dealing with. So that's all that we've got for you here. We're going to be adding on to our formulas as we move forward. And that's where we want to make sure we're keeping things kind of straight.